When working on active construction sites, you must be prepared for storm events and to deal with the resulting water run-on and run-off. Unprotected soil particles can easily become dislodged and the resulting sediment can be transported to separate storm systems and connected waterways. This video is the second in a series focusing on active construction site best management practices or BMPs for handling stormwater runoff, including erosion and sediment control. In this video, we will cover the practices that can control and manage the run-on and run-off on a site. The topics in this video include diversions, check dams, slope drains, channels, dewatering, and emergency routing and spillways on plans. Diversions. Diversions can either be temporary or permanent practices. We will review temporary and permanent diversions as well as perimeter diversion dikes. What is a practice and what does it do? A temporary diversion is a stormwater control measure consisting of a temporary ridge, excavated channel, or combination of a channel and supporting ridge constructed on a predetermined grade across a slope to collect stormwater runoff and divert it to a treatment device or stable outlet. Permanent diversions are similar but have a permanent channel that will stay on the completed project site. How does it work? It works by temporarily directing stormwater runoff in a controlled manner to a desired location and protects work areas for stormwater runoff. It can also be used to manipulate watershed areas for sizing of sediment controls and measures. How to install. Construct the diversion to dimensions and grades shown in the construction plans. How to maintain. Remove sediment from channel to maintain positive grade. Check outlets and make necessary repairs immediately. Adjust ridge height to prevent overtopping. How to inspect. Inspectors should check for evidence of sediment in the channel as well as the outlets for evidence of sediment and to determine if they are stabilized. Perimeter diversion dikes. What is the practice and what does it do? A perimeter diversion dike is a stormwater control measure consisting of a dike or dike and channel constructed along the upslope perimeter of an unvegetated construction site to control stormwater runoff from undisturbed areas and divert it around the construction zone. How does it work? It prevents stormwater runoff from entering a construction site, thereby reducing erosion potential and the volume of stormwater runoff that will require treatment for sediment capture. How to install. Construct the diversion to dimensions and grades shown in the construction plans. How to maintain. Remove sediment from channel to maintain positive grade. Check outlets and make necessary repairs immediately. Repair dike to its original height. How to inspect. Inspectors should check for evidence of sediment in the channel, as well as the outlets for evidence of sediment and to determine if they are stabilized. Check dams. What is the practice and what does it do? A rock check dam is a series of runoff control structures consisting of geotextile fabric and aggregate placed across drainage channels to slow stormwater runoff. This measure may also provide limited effectiveness as a sediment control measure. How does it work? It reduces erosion control and flow velocities in a drainage channel. How to install. Install filter fabric, riprap, and aggregate to dimensions and grades shown in the construction plans. Install the smaller filter stone on the flow side and properly shaped so they are lower in the middle to allow for water to flow over instead of finding its way around them. The check dam should smile at us. How to maintain. If significant erosion occurs between dams, install an erosion-resistant liner in that portion of the channel. Remove accumulated sediment when it reaches 1/2 of the height of the dam to maintain channel capacity. Allow drainage through the dam and prevent large flow from displacing sediment. Add riprap and aggregate as needed to maintain design height and cross-section of the dams. How to inspect. Inspectors should check for erosion between dams, sediment accumulation, as well as appropriate riprap and aggregate amounts. Slope drains. What is the practice? What does it do? A temporary slope drain is a temporary stormwater control measure consisting of flexible or rigid tubing or conduit placed and anchored on an unvegetated slope to convey stormwater runoff from the top of the slope to the bottom of the slope without causing erosion of the slope surface. How does it work? It temporarily conveys stormwater runoff down the face of a slope without causing erosion. How to install. Install an anchor pipe as shown in the construction plans. Use practice to capture sediment-laden water discharged from the pipe. Place slope drain inlet section at the bottom of the diversion channel. How to maintain. Clear sediment or trash accumulation from inlet and restore to proper entrance condition. Repair fill over the pipe. Repair pipe anchors or leaks. Clean and repair the outlet or extend if necessary. How to inspect. Inspector should check the inlet for sediment or trash accumulation. Check the fill over the pipe for settlement, cracking, or piping holes. Check pipe for evidence of leaks or inadequate anchoring. Check the outlet for erosion or sedimentation. Channels, grass, and riprap lined. What is the practice? What does it do? A grass or riprap lined channel is a stormwater conveyance measure consisting of a natural channel or constructed channel, shaped and graded to required dimensions, stabilized with either suitable vegetation or riprap, and used to convey water in a non-erosive manner. How does it work? It carries concentrated stormwater runoff from a small watershed area to a stable outlet without damage from erosion. How to install. Shape and construct channel as shown in construction plans. For grass channels, stabilize channel with erosion control blankets, turf reinforcement mats, or sod. For riprap channels, place geotextile fabric or aggregate filter medium for stabilization and filterization on the compacted and smoothed foundation. Install riprap. Then for both types of channels, stabilize outlet. How to maintain. Remove any blockage and make repairs. Stones may need to be replaced. Remove significant sediment and debris from channel to maintain design, cross-section, and channel grade and to prevent spot erosion. How to inspect. Inspectors should check channel outlet and road crossings for blockage, sediment, bank instability, and piping or scour holes. Dewatering. What is the practice and what does it do? These practices are designed to remove sediments from accumulated stormwater or groundwater that needs to be pumped out of the site to allow work to continue. Once the sediment is removed, the water can be pumped safely into a stormwater conveyance and released into nearby water bodies. Dewatering frequently involves the use of submersible dewatering pumps, centrifugal trash pumps, skimmers, or the application of vacuum to well points. On construction sites, care must be given to prevent discharge water from causing erosion and from waterborne sediment from being discharged beyond the construction limits. How does it work? Dewatering works by either actively with pumps or passively with skimmers or via evaporation, removing water from an area where excavating activities are taking place or are to take place. Control of discharge water and waterborne sediments may be accomplished with vegetated filter strips, dewatering bags, flocculants, sand filters, rock splash pads, skimmers, rock check dams, rock filter berms, turbidity barriers, silt fences, filter socks, erosion control blankets, geotextiles, geomembranes, or other means to control erosion and the release of sediment beyond the construction limits. How to install. The operator will furnish, install, operate, and maintain all drains, sumps, pumps, casings, well points, cofferdams, skimmers, and all other equipment required to properly dewater the site as specified. Volume calculations are performed to size the active or passive mechanisms for dewatering. Knowledge of site topography is used to install a dewatering system that will prevent erosion or sedimentation. A water or soil test is conducted to determine the appropriate flocculant agent necessary to clarify turbid water. Water volume and dewatering rate calculations are performed to determine appropriate erosion control, sediment, and flocculant capture and containment within the construction limits. When BMPs are no longer needed, the contractor shall exercise extreme care during the removal stages to minimize the loss of soil sediment and debris that was trapped during construction. Pipes, casings, and any other material used to dewater the site shall be removed from temporary wells, which are then filled to ground level with clean gravel or other suitable material approved by the contracting officer. The contractor shall exercise extreme care to prevent pollution of the groundwater by these actions. How to maintain. Monitor and maintain to ensure the removal of water from the construction site is accomplished in a manner such as the erosion and the transporting of sediment and other pollutants are minimized. Dewatering activities shall be accomplished in a manner that the water table water quality is not altered. How to inspect. Check the inlet, check all components for sound operation, check dewatering system to ensure that no erosion is occurring and that sediment transport beyond the construction limits is minimized. Emergency routing and spillways on plans. By using the BMPs previously mentioned, you should be prepared to manage run-on and run-off. Now we need to consider a backup plan. If a heavy rain event were to occur, is your site ready to handle it at all times during the various stages of construction? Emergency routing and spillways must be shown on SWIPs. Make sure the progression of the work on the site does not interfere with the emergency routing plan. If construction is going to start in the area where your run-on or run-off BMPs are located, then these practices need to be moved and the stormwater flow redirected prior to the start of the construction in the area. Otherwise, your BMPs will not function properly. In conclusion, when you prepare for and properly manage stormwater coming onto and running off of your project site, this will help to prevent unexpected permit violations. Please refer to local and/or state regulations and technical standards that contain the detailed requirements for your project site. Thank you for doing your part to improve the water quality in our local, state, and national water bodies. Our next video will discuss BMPs needed for surface stabilization.